Hello and welcome to the Conscious Design Podcast, where sustainability meets innovation and business savvy. I'm your host, Ian Peterman, CEO and founder of the Peterman Design Firm, a hub for green tech and visionary ideas. Join me as we dive into the world of conscious design. Today, I'm excited to have Manuel García. He's a co-founder and CEO of Nagami, where they're combining creativity, technology, and sustainability to create 3D printed projects using recycled plastics. Welcome to the show.
Thanks, Ian.
So everybody loves a good origin story. Let's talk a little bit about the origin story of Nagami. How did this project come about for you guys?
Yeah, so Nagami is like a Gabriel project, I guess. It's a crazy idea that started evolving by its own with lots of effort, but also lots of enjoyment. I'm an architect. I specialize in digital design. So since my early days, I was very passionate about sci-fi movies and 3D modeling and animation and so on. So I went to study digital architecture at the AADRL in London. And in there, that was back in 2011. No, 2009, right? And I finished in 2011. It was a very interesting moment when the digital started to become physical as well, right? So we were not only playing with forms and shapes that could not be conceived with the tools we had at the moment, but we were also starting to find ideas on how to materialize them using new machines, such as 3D printing, using industrial robots. And it was a very vibrant moment in the history of architecture that then continued to evolve in my career at the Bartlett School of Architecture, where I started running research lab together with my friends Jill Retzin and Moni Claypool. We set up a very ambitious agenda that was mainly based on how to use, again, robots to create forms and shapes that would be inconceivable otherwise, to make architecture more robust, faster to produce, safer, and even cheaper. And then the main research thread in there was 3D printing. So we started playing with small 3D printers just to, add the printing head to a robot and see if we could print bigger, but of course it would take forever to do it. And then create our own tools. 2 years later, the research was very well published, very well received by the design community and the tech community as well. And the Centre Pompidou asked us to develop so I didn't know how to start. I didn't want to continue in an academic framework and thought that perhaps in the future, there will be a space for 3D printing to really disrupt the design market, the furniture market, and further on architecture. And the way to get there would be through creating a startup. So kept thinking about it, thought that London was a little bit difficult, a little bit unaffordable to start such a project. So one day I just thought, well, maybe we just do it in my hometown in Avila, which is next to Madrid, 100 kilometers from it. And maybe my brother is interested in joining. And in the end, not only my brother, but also a friend of ours, also training architecture, decided that that was a cool idea to get on board. So they would spend a whole year developing a plastic extruder in my brother's apartment that still smells like plastic. While I was programming and designing and creating a brand strategy to create not only this object, but then continue developing for, maybe a few years down the line, get real objects in the market. We launched the chair. It was materializing a chair, right? This research was called the Voxel chair. We launched it in 2017. And it was an object that you couldn't conceive with any other technique, right? We also chose a Panton chair as a base. The Panton chair is the first design object or design chair made with plastic molding. So we thought that this would be the right reference for a new paradigm, right? A technique that was yet starting to exist. So it's a version of this Panton chair, but created as a volume, as a line that materializes in the air, right? And that changes density and opacity. So the chair was very successful, very stressful as well. And because it wasn't stressful enough, we decided to go through another stress period to launch the company in 2018. And we chose Ross Lovegrove, Zaha Hadid, and Daniel Wildrick to accompany us in this journey and develop a piece with us that would be completely extraordinary, right? That would be something that could only be achieved through the technology that we were developing. So 2018, finally, we launched these 4 chairs in Milan Design Week. And it was, to be honest, probably the most special moment of the company still until now, when we really saw a new paradigm coming through. And from there, we had it very clear that we didn't want to limit ourselves to exhibition pieces that would be unaffordable, that would be only living in vitrines and museums and galleries. But that was really an excuse to develop that technology further so that we could create chairs that people could actually buy, that would compete in an actual market. That has been a little bit our journey from them, right? Like developing the technology to make chairs that would be, could sell for 500 euros. Then from chairs go to, full interior panels, facades, and even small pieces of architecture, which is where we are.
It's a great journey. I definitely see it's a lot. That's a lot to accomplish in the last few years. So sticking through, I feel like that's one of the important things, right? Is sticking through. And I love that you started with, okay, academic, right? You're purely research based, found somebody who was willing to, wants to be a display piece, but that's fine, right? That's a starting point. So I love your thinking is it's an excuse to develop it, right? So that you can make it actually tangible for the average person and not just behind glass, sitting somewhere that, it'll get lots of attention. People will write about it, but there's a difference between I read an article about this thing and I can buy it and I can have it and I can every day experience something, which is, I think that's how you get people to think about something and get people to engage with new materials and new technology. A great origin story for how you got here.
Yeah, you're framing it very well. It's basically, it's not that innovation is easy, but you can be very innovative. But if that doesn't translate to the real world and people can actually buy the result of your innovation, then it will not become meaningful.
Let's talk a little bit. So technology, you started obviously the research, you've developed your own technology, 3D printing, even a chair, right? Even like chairs that we're sitting in right now, this size is not something that your average 3D printer can do. So you guys, I've looked through your website, looked at everything. You guys have developed some really unique 3D printing technology. You didn't have these really nice robots starting off. So talk a little bit about this journey of how you went from research lab, working on it, to now you have really great, these amazing pieces of equipment that can produce all kinds of things. What's the technology behind that?
So basically, for us, technology was a tool that we needed and didn't exist, right? We were dreaming with beautiful objects and beautiful spaces were impossible to materialize, right? So the first thing was to check, okay, we're going to go with plastic. Also, back in the days, sustainability was not that mainstream as it is today, but we had it very clear that we wanted to evolve our technology to work with recycled plastics.
Most people don't do that.
Exactly. And it's way more difficult than to print with virgin plastics. So we started looking at the market and see if any plastic extruder that already existed, right? They were ready for printing horizontally. Of course, out of naivety, we thought, well, maybe we just take it and turn it around and add it to a robot. And no, it didn't work, right? So and that's something that we were already investigating in the lab. So when we started, we didn't have means to, create an LSX screw, for example, to push the materials. We were looking at like blueprints for plastic extruders and see what we can change for it to work in a robot. But it was really inaccessible for us. So one day we just found out that if we get a drill bit, that's like a drill bit for wood, and can create a cylinder, basically wrapping it, and then start like playing with more and more components. We finally finally managed to extrude plastic. But it was very difficult, right? Like it wasn't as it is today. It's not that we press the button and it goes, but it's getting close. That is what we actually did for materializing that first chair. Since then, we've been evolving that same extruder, of course, now with a good endless screw that we very happily manufacture from the money from our first or second project, and started evolving that tool. Now we are in the 7th version. Of course, we have more functionality. It's working very well with the software that we are developing as well, right? So a colleague of ours was developing an open source plugin for working with robots in architecture. And then together we basically just did a specific version of it. So he would do the core and we would be plugging in more and more functionality. And after 8 years, that's basically a jungle of functions here and there that one day we need to put again in order, but that is working perfect for the technology as both are coming from our hand, right? So every project we do, we try to push it to the limits. And then we find out that we need to add more functions, more tooling, to print with 2 robots simultaneously, to print with 2 robots in multi-move when one is printing and the other one is drilling. I think we are just really at the beginning of the whole ocean of possibilities that this technology can bring us.
I love those stories, starting to use with a screw or wood screw and working from there. But it's so, I think there's something to be said about that process, though, of sometimes you just have to grab something close and start there and see, especially when you're making something new, right? Like what you mentioned, right? A lot of our early 3D printers, it was only horizontal. It was only made, you could only print in certain ways, and you can't do what you need to do, which is articulate this extrusion at many different angles, right? It's not just top down. It's not just on the side. It's almost more like a CNC system.
Yeah, I mean, it's a 7 axis. So in the end, what we're doing is, if you imagine, the robot is a robotic arm. So if I get, a pencil, I can draw into space. But if I get a machine that is extruding plastic and I can choreograph that movement, I can actually take advantage of every single axis in my body. Obviously, if we use an industrial robot, I don't have to be there for 7 hours printing one piece. And it would also be more precise.
Now, material-wise, right, you now work in recycled plastic, which I worked in 3D printing for a long time, played around with it, worked with people in it. It's hard. It's not typically, there are some more companies out there now making more recycled 3D print material that you can reuse, right? The spools and everything, but it's really hard. Let's talk about that journey a little bit. When did you first be able to add recycled material, and how are you 100% recycled now? Kind of where are you at?
Yeah, that's a good question, because yes, it was a painful journey at some point. So, I mean, first, of course, we just wanted to get extruded to work. Because we didn't want to work with a non-sustainable material, we use PLA. Not recycled, but biodegradable. Actually, the boxer chair is made out of PLA. Then slowly what we did was to change the material mainly to PETG, although now we use many other kind of plastics, and start adding a percentage of recycled plastic, and slowly going larger and larger and larger until we reach the 100%, right? Like this is 100% recycled plastic, right? Still, recycled plastic has like different, degrees of quality. If you get plastic that has been captured from the sea, that's really bad quality. And if we get, for example, plastic from, single-use medical equipment, that's actually a much better quality. So what we're doing now is to change this mix depending on the structure or the structural quality that the object needs. Right? So if it's a lamp, it doesn't have to suspend a human body. Then we would use 100% recycled plastic. But if we're doing a chair, 100% or a higher degree of bad quality recycled plastic. And if it's a chair, we would actually mix it up to keep up with the strength of the object, right? We are also working with other materials, and we have a few different partners. This one I have here, for instance, is mixed with cork, right? And it gives a different aspect. It also has a different kind of elasticity.
So cork is actually in. So it's a plastic cork blend. So cork is in.
Yes, exactly.
Okay, very interesting.
Yeah, polymer. This is PET with cork, right? Or we have. I don't have it here, but we have other ones with coffee grain, with ostrich, with there's plenty of different options with algae, with pine. Yeah, now we're actually mixing polymers with almost everything, right?
And so you're still able to put it through the same. Do you have to change your machine at all, your 3D printer, or are you saying no? This is our 3D printer. We're gonna get it to go through.
No, so we mainly work with partners. I mean, it's true that sometimes we actually just mix a component like coffee powder in the extruder and it works. We're playing a little bit with fire because it could be that the extruder gets blocked, that the density of the material is inconsistent. But yeah, we mainly work with compounders that are partners of us that create the pellet that already contains that mix. Right, so it goes to more to the chemical level, right? It's not that we're mixing it up in the extruder. Still, every new compound, we need to test it slowly to make sure that the ductility is right, the quality is right, that then the shrinkage of the plastic when it dries doesn't break the object apart. So it's an entire world of new possibilities. The same piece printed with one plastic or another could lead to incredibly different results.
Right. I've heard of, like 3D printing, glass filled is pretty, like you can get glass filled nylon is pretty easy to get. But I've not heard of anybody, you're the first I've heard of mixing in actual coffee grounds into your recycled plastic and having it work. And what you just showed with the cork, that's amazing that you're able to do that. And I love the idea of blending, right? Because it's a really good point, and people don't think about the quality of a recycled plastic. If it's sat in the ocean, right, the ocean eats things. The salt water, it's not. It'll eat it away, right? Compared to medical, right? But being able to blend those two, I think, is great because I think a lot of people are like, oh, we need to use all the plastic, right? But there's not always a good use for a low grade plastic. But being able to blend it, right? People think of, oh, I'll take virgin plastic and I'll blend in some recycled plastic. But I love your approach of going, now we can take really high quality recycled and blend in some bad quality and use this material into something and make it still functional.
Yes, you need to learn how to basically listen to the material, what it wants to be.
Yes. Yeah, it's not every material is perfect for everything, but you can find a use for it more than likely if you just think about what the properties are.
Yes. It's part of the design process.
Yeah. Yes, it is. How big can you print now? I've seen some pretty big things that you guys have printed. Are you trying to grow that more and more? Is there a size, is the doors limit the size limit for you? Kind of, how are you?
Well, we elevated some of the robots to print up to 3.5 meters tall in one go.
Okay.
And that now will be, depending on the geometry, but that will be around 35 to 40 hours, which is, that's something extraordinary, meaning that you can print a 3.5 meter sculpture, just one, and then print another one completely different. Right? And that is a complete shift in the way of understanding manufacturing, right? Being able to print such large pieces without creating molds, without creating a manufacturing chain, right? It's really giving an alternative to the Henry Ford model, right? Where it's lots of machines connected in line to create a single product over and over again. As Henry Ford was saying, it can be in any color as long as it's black, right? So even the color is the same. To make the process more efficient, now we have a machine that can create an entire variety, like almost endless variety of products, right? That is a paradigm shift, right? We don't need to create a stock. We can, the machine, like that same machine that is elevated to print up to 3.5 meters, can as well print a bus like this one, right? Which is nothing, right? So, we can just respond to the demand almost automatically, right? And that's part of the magic of this technology, which is actually not only limited to the material, it's also making the entire manufacturing process much more flexible, much more versatile, and much more sustainable.
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
So even your one that's elevated up, it can still just print. You don't need to do anything to it. It'll just print a tiny, it's this little tiny thing, and then it'll, in 40 hours later, build some massive sculpture. Are you, because I know you obviously do sculptures and display things, right? These larger pieces, but then you're also really in this, let's make chairs, faces, more, I guess, interior design items. Is it a shift? Is one side bigger than the other? Like, do you do more furniture? Is that your goal? Is to be more in that range, or in these sculpture type things?
That's a very interesting question, because when we started, we didn't know what the market would be for 3D printing at this scale. We're still not completely sure, right? So we're testing the market. We're actually 3D printed objects at this scale didn't really hit the market back in 2013, right? So we started with chairs because we're architects. And architects traditionally test their ideas on chairs. Actually, if you look at most seminal chairs, right, are designed by architects. It's a way for us to, check principles, formal principles, structural principles. It's still a small building. It has to support a human body. As a building has a slab and needs to support people, right? So many of those principles have been traditionally tested through chair designs, from Gaudí to Frank Lloyd Wright to Rietveld, right? That then were developed in architecture. We follow the same path. Also, it's obviously way cheaper to test things in a chair than test it in a building, way faster, right? Yes. So we thought, okay, chairs would be the ideal start for testing, and also start checking how the markets would actually absorb these new elements, disrupting it, right? So it started from chairs, then developed all the kind of catalog pieces within the furniture realm. But our objective was always to create larger elements, right? Like, we're still architects and we're obsessed by doing architecture and create spaces that we inhabit. So we started getting more projects. Like, we work a lot with high-end fashion brands such as Dior, Jimmy Choo, or other brands like Cartier, etc. Right, with hotels as well, such as W, and it was projects. It still is, right. So projects that are ideal for 3D printing. Why? Because those brands want something specific. They want their own design, right? Like, for example, Dior. When we did this facade in Marbella, and we also did a window display in Bodrum, and they are creating a collection, and everything surrounding the collection has the same thematic, and it stays for 6 months. So after those 6 months, they just throw it away, build a new one, right? For us, creating something very personalized for you right? That's just the Dior facade. No other brand in the world will have it, right? The furniture for Jimmy Choo, that's just for Jimmy Choo. For us, it's actually pretty easy, right? And we can have a very smooth conversation with the client about representing their brand ideas and their brand identity into the furniture, into the walls, into the facade, right? We build it with recycled plastics, and if it's something temporary, then we just take it back and we shred it and reuse it in our own facilities, right?
Anything that's temporary, you'll take it back and be able to regrind and reuse it.
Exactly. If you want to buy a chair from us and then you're tired of it, we can shred it, right? That a chair, a facade, or anything. And we do that with lots of projects, right? So basically, 3D printing really became the ideal tool for fast, sustainable personalization, right? So lots of projects really emerge in that category, and we've been increasing our capacity with those projects. Basically, using all the profit of the projects and just getting more robots and more people and being able to get more projects. So now we have 22 robots. We grew from one robot in a garage in 2016 to then 5 robots 1 year ago to 22 robots now. So, for example, if a brand wants to, dress every single soap in the world, we actually have the capacity to do it and do it fast. At the same time, right now, even if most of the work we do is project based, or we're diverting a big part of our work for furniture, not only catalog furniture that we sell, but also personalized furniture. Like imagine you are, you have 5 offices in the States, right? Or you're Google, right? We're not working with Google yet.
Yes, I like that.
Exactly. Yeah, I'm not trying, but so imagine you want a specific chair or a specific table for all your desk. So we can just develop it for you, and that is we can actually get a very cost-effective process because prototyping phase is relatively short, and we can get to a medium edition. Like, let's say, I don't know, maybe it's 500 chairs. Like we recently did a theater, personalized furniture, but it was only 500 chairs and 250 tables. You can't do that with injection molding. You can't do that with an artisan because the price for it will be insane, right? You can't really offset the initial cost.
Yeah, just the molds for doing a chair are as expensive, right? You're talking about potentially hundreds of thousands of dollars in tooling before you actually make anything. That's just setup. And if you mess it up, you get to pay for it all over
again. Yeah, yes. If the mold is wrong, someone will get fired.
Yes, someone gets fired and you get to do it again. Not a good model for that.
For us, it's extremely easy. Like we design a chair, we print it, we test it. Oh, it's not comfortable. We change the 3D model and we print a new one even in the same day. So prototyping goes incredibly fast and incredibly inexpensive.
When you work with people on these projects, because you mentioned there's a lot of design that goes into this, right? Because you don't, it's the same with anything else. You have to actually design what you're going to do, not just click a button yet on a 3D printer.
Yes. We're far from it.
How long do you need to do any special design process with this? I know with like different 3D printing, there's like infill and you do support structure. Like there's a lot that sometimes goes on the inside. Do you need to do all of that? Does that happen, or is your 3D printing process different in some way? It doesn't need all that support material just to print.
It's completely different. Sometimes people think that it's just scaling up this technology to make it large. No, it's not. And it's actually not that it doesn't need support material. It's that you can't really add it, right? You can only add it if you are going to mill it afterwards. But if you want to be true to your process and have this line texture, right? This is the deposition of the extruder, right? So you want to have a line that goes through the object, maybe then it does something different inside, but it always gets in and out, and one line on top of the other line, right? If you start printing like very deep angles, the material falls because this is not a small thread like in an FDM, a small 3D printer that would dry much faster. This is thick, and that's why we print fast. So as it's thick, it also weighs more. It's way more heavy. So gravity is always your enemy. There are different ways to kind of deal with it. The one that we support the most in Nagami is really playing with it, playing with the limitations and the opportunities. Like design with, from, and for 3D printing, right? If you start, I don't know, you want to design a piece like this piece that has like lots of holes, right? Then that becomes difficult because if you print a hole here, then that material is floating in the air again, right? Besides, you need to stop printing and then continue. And this is it's like toothpaste, right? Because it's thicker. So every time you cut the material, you see a little imperfection that, perhaps is a desired effect, but sometimes it isn't. So every project really becomes unique and needs to kind of be adapted and evolve with the technology itself. One day we will perhaps be able to press the button and print anything with support material like a giant SLS machine, but I think that day is still far. And we're having a lot of fun in the meanwhile, thinking about these issues.
I think it's not every process has to be or accomplish the same things as another one, right? Like 3D printing, FDM, it has its place. However many other acronyms, SLA, right? There's a bunch of different versions. They all have a really good use and they have a place, but none of them can do this. And I think that's also okay, right? I mean, obviously it would be great if there was like one perfect process that could do every kind of thing, and that'd be magic, basically. You could make anything, any angle, do all this. It just floated in the air where we needed it to, right? That'd be great, but we don't live in that world yet, at least. So I think it's really okay to go, hey, this is the process. This is what it looks like, and embrace it. Like what you're saying is, no, this is the style. Like if you don't want this style, then don't. We're not the solution, right? This process, this technology.
Yeah, exactly.
If you want it marble, don't come to us. You need to go have it made out of marble. If you want this has a specific look. This is the process. And I love that you're just embracing that and not, I mean, obviously you're trying to improve, but it's not stopping you. You're not going, oh, well, it's not perfectly smooth, so we can't do it. You're just going, oh, this is what it looks like. And it looks great.
Yes. It's actually, it's a very interesting one because, say maybe 60% of our clients, they come and the first thing they ask is if we can get rid of the lines, right? And our answer is like, well, yes, but it will be more expensive because you need to mechanize it afterwards. And they keep on thinking. Then they see the objects, they come to the factory and they're like, no, I don't want to get rid of the lines. I mean, that's the most magical part of the object. There's a texture that doesn't exist outside this world. So it didn't happen a single time that we had to get rid of the lines in the end. It will happen, but just not quite yet.
Well, I think, that's a good point too, right? If you were using another process to try to make it look like that, it would be very hard. Like I can't imagine the work it would take to try to make that what you were just showing another way. That sounds very expensive and hard to do. Whereas this is actually the cheapest. This is the base. This is what you get. This is the look. So I think that's always something I love. I love that nobody has wanted to change it once they see it. Like I love that. That's great.
Exactly. Yeah, me too, to be honest. I love this effect. I mean, maybe one day we will just be tired of it because half of the world will be 3D printed, and but for sure we will have invented another method. So yeah.
Exactly. Yeah. In 30 years, when we're tired of that style, someone will have created a new process. We can all look at that novelty, and I mean that's what we do. Though we develop a technology. It looks cool. It's interesting. It's different, and we use it. I think it's and this is a great technology to have. Now, kind of to wrap things up a little bit, I'd love to jump into the future with you. I know that you're obviously improving this process. You guys have come a long way from having this a robot in a garage and in apartments and in a lab, right? Where do you see this going? Is this something that, because I'm thinking of, you're talking about facades and things like that, putting it on the outside of buildings. And like, where do you want to go though with this technology moving forward?
One of the reasons for starting this company, that again really came from architecture, is because like plastic waste is almost, we call it unfortunately unlimited material source, right? There is right now 8 times more weight in plastic waste in the planet than in people, right? So each of us own 650 kilo per capita, right? The reason for this is because there are not too many applications for plastic waste. And the applications we have are not in the volumes that would actually fight the rhythm of waste that we put out there, right? And for us, the key to really change this balance is architecture and construction, right? Once a material gets into architecture, then the volume, the mass of that material that gets used increases radically. And that's one of the reasons why we are trying to go more architectural, to go bigger, right? To start working on facade systems. So, we're creating a small pavilion. Well, small, it's like a 9-meter diameter, fully printed with recycled plastic that has a 3D printed structure, 3D printed facade, 3D printed interior, furniture, everything, right? I think slowly we start discovering more uses for this material and this technique within the architectural domain. So somehow between increasing the amount of recycled plastic that we use in our interiors and our furniture, but also developing new methods, new materials, new technology to make it a robust solution for architectural systems, that will really start changing the curve of plastic waste in the planet, right? So that's our goal, not only because we are architects, but also because I really do think that that's a mission that a company like us should definitely embrace.
We'll definitely keep an eye out for that pavilion when you can show us that pavilion. I think it'd be a great way to show off the technology, and that would be, I can imagine so many uses for something that's temporary, because you could easily go shred it and go make another one for someone. So there's that ability to, right? There's a lot of people that make plastic products. I don't know of any really that have hey, we'll take it back, shred it, and literally use it to make another product again. So I think that like that layer just by itself, even if you didn't use 3D printing, you use something else, but you were able to do that. Like that is a huge piece to making it more eco-friendly, right? More sustainable.
Yeah, exactly. That is the real circularity.
Yes, that is true circularity, where you can produce a product, bring it back in, shred it into a raw material, and go make the same product again, even, or do a new one, right? You're able to do that, and I love that. So I'm excited to see that proof, that demo when you build that.
Me too. I can't wait to finish it.
I know.
Yes.
I can only imagine, right? You've been working on this for a long time. Like that's going to be a really big step for you guys, and showing off, hey, this is what we can do, because that's 9 meters. That's a big thing, and it's structural. And I think that's a big piece, because you cannot just FDM a structural piece like that. You can't use 3D printing like what we use for products. It's not something I'm going to go stand on and trust. It's
No,
sure.
I really don't think so. No. Yes.
So you guys should have like a dance party or something on it and have people jumping. That'll really show how well it can survive people on it.
Hopefully soon. I will start printing the disco ball.
There we go. There we go.
Yes.
Well, this has been amazing. This is a great technology. I love that you're able to utilize otherwise garbage plastic that other people are just not able to use in a smart way, and you're able to do this and make things that no one else can make. For people that want to reach out, that are might be interested in buying your products, whether it's a chair or a facade, or maybe they'll just get this whole thing to set up so they can have that in their wherever. What's the best way to find you guys? And then anything you want to add.
Mm-hmm. Well, you can check our website at www.nagami.design. Same hashtag in Instagram, so nagami.design. And we also have a showroom in Madrid, in the very center of Madrid, in 𝗏𝗁. So come visit us. We will be more than happy to show us our products. And if you want to be a little bit more adventurous and want to walk into a laboratory with 22 robots, you can come visit us in Avila in our manufacturing facilities.
Fantastic. Well, thank you. I really appreciate you taking the time. We've been really enjoyable. Hopefully you had fun talking about what you've been doing. And yeah, thanks for being on the show.
I love it. Thank you so much. It was a real pleasure.
And that wraps up another episode of the Conscious Design Podcast. If today's episode inspired you to bring your product idea to life and turn it into a sustainable 7-figure business, visit 𝗏𝗄𝗯𝗹𝗲 or click the link below. Your ideas have the power to change the world, and we're here to help make that happen. Thank you for joining us, and I'll see you on the next episode.